So on to this next session, which is brought to you by our partners at Enlight Software and presented by Jeremy Clute. Jeremy Clute is VP of Business Development for Enlight Software, where he's responsible for driving new growth through the creation of valued partnerships with industry-leading companies to expand Enlight's business and portfolio. Jeremy's worked in software for 20 years, and nearly half of that time has been spent in the data center network, working at Emerson Network Power, and through their transition of that business to Vertiv that we know today. This session will explain how integrating all layers of the data center from the physical down to the IT and workloads opens up opportunities for optimization and simplification across planning and operations. Referencing European case studies, this presentation will show how end-to-end visibility across the entire hybrid computing fabric has enabled accurate decision-making and scalability. And with that, Jeremy, over to you.
All the attendees today, and I'm looking very much forward to presenting today with you guys because I understand and have seen lots of the input and the conversations that have been going on already today flow very well into and with the topics that we'll cover today. So as Chris laid out, we'll talk about integrated data center management in a new world. And first, I'll take a look at the agenda. And normally I would think looking at integrated data center management is part of my topic title. It might be something that I close with, but in fact, what I'm going to do is propose that we open with integrated data center management and start talking about then all of the key items and the key areas of investment that you should consider as data center owners and operators that basically you would leverage integrated data center management as a building block, as a foundation. And so we'll talk about integrated data center management as well as a few other items. We'll talk about analytics and the importance of analytics to the data center environment today. We'll look at security. We will definitely get into talking about sustainability and the implications of that, as well as the fact that it's one of the major trends going on in the data center environment today. And then lastly, just wrap it up with a discussion around metrics and benchmarks. So moving forward, what I would say here is first covering integrated data center management. I want to then look at the uniqueness of data centers. So I don't know if you guys are like me, but whenever I am tasked with trying to explain to family and friends what I do for a living, it always starts at the data center, and explaining what a data center is pretty abstract, I think, to a lot of people. Most people leverage their mobile devices to access everything from banking applications to social media and you name it. And they don't really ever understand or think about the underlying facility, the underlying IT infrastructure that is supporting all of that content that they're looking at on a daily basis and minute to minute. Data centers are certainly unique from other building types, and not just because they're data centers serving a greater need, but also because they are greatly impacted by the building itself, is impacted by the applications and workloads running inside of it. So everything is sitting there needing to work together in a very efficient way in order to continue to provide efficient content or processing or whatever the task is, whatever the work load is for that particular business. Historically, IT and facilities have been planned and managed separately, and I think we all know that if you've been in the industry for even a decade or it moves so quickly that you can see things changing greatly from time to time. But I will say that as we look at the data center today, it's definitely under ever greater scrutiny than what it was before in terms of the need for organizations to want to drive efficiencies. As we talk about sustainability and security and things going forward during this presentation, it's really, really important that data centers be managed intelligently and comprehensively. It's really not suitable anymore to look at managing individual portions of the data center itself as individual silos. Keeping facilities separate from IT is really becoming a wayward, a thing of the past, if you will. What we really need to leverage is end-to-end integration and use cases. And again, if you were talking about this with anyone 10 years ago, there would be a lot of, well, that's not necessarily my area of purview, that's someone else's area. And so organizations certainly are going to be built with teams based on core competencies and so on that suit them best. But the idea that any of that needs to be managed or understood separately is definitely becoming a thing of the past quite rapidly. So really the optimal approach to this, to address the requirements that data centers are facing today, is to make sure that you are comprehensively integrating all of the disparate systems that manage the data center and share the data that is relevant, and then provide analytics and metrics over top of that, as well as improving your processes and so on. So we'll continue to discuss that as we go forward. So real quickly, at a glance, integrated data center management in our parlance would indicate the tight integration of all the systems in the data center for purposes of energy savings, reducing costs, improving resiliency and uptime, and ultimately what I would say over top of this is you have to ensure that you build in some level of flexibility with all of this. The reason for that is as things change, right, as the environment changes, as you get better and better information about your environment and how it's operating, that flexibility, built-in flexibility, will always enable you to then tweak, right, and make more gains as far as optimization is concerned. If you start to think about, people in the data center world have been managing and monitoring and reporting on the effectiveness of things like power usage for years and years, over a decade, right? And we've always been talking about multiple types of metrics that might be able to come into play to help us with this. So the key is that until you really fully integrate the systems that are operating the data center, you will be hard pressed, I think. At a certain point, you will run out of room to make improvements if you don't have a full picture. And so I would propose that rather than thinking about, oh yeah, we'll do the integration of these systems at some point in time, rather start there. Let's start with the integration of those systems, and then we start to uncover all of the details about the data center itself and where we can drive greater efficiencies and optimization, and ultimately improve everything from costing to uptime to environmental impact. So we'll move on here. Okay, so just again, some of the benefits, and then we'll move into some examples. So first things first, increase efficiency of power, cooling, and space, right? So really we're thinking about the efficiency of your capacity, managing your capacity effectively, managing your capacity optimally is a key target and a key benefit of integrating your data center. Improved effectiveness, certainly, right? So being able to manage and look at things like pre-planned maintenance. Every vendor will, whether you're getting hardware or software, you're going to get some kind of recommended maintenance, some kind of recommended service window, and so on. But the more you can integrate your systems together and then analyze the data that those systems create, the more you're going to be able to tweak your effectiveness based on what's actually happening in your environment and not just taking anyone else's word for it. Those should always be looked at as guidelines, whereas what you're proposing or what you're creating and getting and generating out of an integrated environment would be real world data that then enables you to make decisions and be more prescriptive with your actions going forward. Certainly you get reduced risk of outages. One of the examples we'll talk about up front here is looking at how do you understand the impact on your critical business workloads of upstream cooling failures, right? And so that's one thing that I'll propose and show here in just a second. And then improve resiliency and efficiency, right? Simulating critical infrastructure. You hear everything around digital twin and so on. So being able to plan for outages, being able to plan for scheduled maintenance windows and things of that nature, and what the impact is on the entire business unit, what the impact is on individual users, and what the impact is to the business overall will be hugely beneficial coming out of this. So one of the things I just mentioned is that integrated data center management introduces the idea of an end-to-end cooling chain. If you think about managing thermal or cooling or what have you in the data center, you know that that is every bit as important as power management. Workloads could be affected by the outage of a particular cooling unit or a series of cooling units or failing sensors, or you name it, in many ways. And that understanding the impact of that is key. It's important also to look at the fact that when you're creating this cooling chain and defining it, configuring it, you want to make sure that there's flexibility built in there. In other words, when we say end to end, what are the endpoints? Where does the chain start and where does it end? Which workloads are really served by which pieces of cooling infrastructure and which aren't? You know, if I have a hotspot in a particular area in my data hall, is it really impacting critical workloads? Is it impacting nothing? And being able to have the visibility into that is key. But I would say that if you ask the question of people, oftentimes, what's the impact to your ERP system if a particular air conditioner goes down? There would be a lot of scrambling to determine exactly what that impact would be, or if there was any impact at all. And so by putting this into an integrated system, this allows you to comprehensively sort of bring the workloads together and the other IT gear into an overall picture of how that cooling infrastructure is serving those workloads, and then also gives you an idea around how can you make intelligent decisions around maintenance windows and managing unplanned outages. So you want to look at something that offers you both a proactive, in other words, scenario planning capability that says, if something were to happen at this point in my cooling infrastructure, what would the impact be to my workloads? But on the other hand, you want it to be extremely capable of handling a reactive situation as well. In other words, now something has failed. What are the SLA implications for this? Who do I need to contact? And what needs to be done about it in terms of moving workloads to a different location, a different environment, what have you. Those are key implications and things that bringing together this end-to-end cooling chain certainly address in a solid and meaningful way. Most data center operators will have all of the information they need to kind of determine this, but it would be located in various and disparate spreadsheets, or it requires the coordination in real time of multiple operational groups inside the data center and so on, and that can take a lot of time. Whereas with an automated integrated approach, you ought to be able to, at a glance, pull the data that says this air conditioner fails, that impacts these workloads, therefore we need to move them immediately and so on, and notify this business group contact and so on, right? So that's the benefit coming out of the identification and definition of an end-to-end cooling chain. You also want to, and this really continues on that theme, align your critical infrastructure with workload demand. So if you think about aligning workloads to infrastructure, what does that really mean? Well, one of the things we talked about is the cooling chain. So that enhances your ability to manage your environment and the workloads that are doing the processing for your business they're absolutely critical, right? They're the core component. They're the core reason that the data center even exists in the first place. This also gives you a lot of benefit in the realm of edge locations, managing edge locations. Typically, you want to have some sort of autonomous and remote management for that, right? Those are not always locations that are heavily staffed, if they're staffed at all. They may be lights out. You know, you may be already leveraging efficient cooling and lighting and space management in a lights out environment where it's effectively an environment based on computing, but not really something that needs to be designed with the human comforts in mind, right? It doesn't need to have certain climate functions. It doesn't need to have certain space allowances and so on. So you can look at it from that perspective as the understanding your cooling chain, autonomous and remote management becomes incredibly important in environments like that. You also have high density computing. Well, high density computing definitely provides you energy efficient cooling options. It lets you do more targeted, more focused cooling operations to keep your workloads safe and functioning well. But at the same time, you know, high density can increase your risk as well with those workloads. So there's a lot of things that you need to think about when you're aligning your critical infrastructure with your workload demand. And the last thing I would say, and you'll see this, and this kind of will run through, especially in our sustainability thread, is looking at free cooling and renewable energy sources at optimal times. So are you processing your heaviest workloads in the most efficient areas or most efficient facilities within your data center organization? So that's that'll kind of round out the portion of and why we want to make sure that we're looking at an integrated approach to data center management. So the next section will run into analytics. Analytics is has really never been more important than it is today. And, you know, just the scale and complexity of modern data centers is creating this obvious need for deep analytics. Several years ago, I would say, we were talking about it and sort of creating ideas around brainstorming around, well, what's the world going to look like in the data center, and what kind of metrics and analytics are we going to actually need? And, you know, there at that point, there's always that a lot of us raise our hands and say, well, we don't know what we don't know, right? Well, not knowing what you don't know is certainly something to be reckoned with. But as time moves on, we start to learn more about what we don't know, and now we're seeing data centers really implementing analytics for several reasons. One, where should I be placing my workloads for, you know, optimal workload processing? What about preventive maintenance and failure prediction? And I have to say, in my day-to-day work, probably the most common thing that comes up in discussions around analytics, artificial intelligence, and machine learning is always around failure prediction. The most common question people want to ask about is, well, what do we do for failure prediction? What does that look like? How can we get better at identifying things before they happen? And certainly that rolls right into preventive maintenance as well, right? But it's more than that. We're also looking at things like anomaly detection. So let the system tell us when our infrastructure is running in a non-optimal fashion, or at the very least, tell us when something is happening outside the normal expected operating status for that device, right? Everybody is instrumenting their systems with alarming and thresholding and so on. So the infrastructure can tell you when it has a problem. The real issue there is that along with that is you can tend to get very noisy notification structures, right? I'm sure many of you operate in environments where you're finding that you get alarms that bounce on and bounce off constantly, even within a minute's time. So this device is an alarm, now it's not. Now it is again, now it isn't. Looking at things like anomaly detection really lets the system tell us, you know, outside and above those thresholds and alarms, where you have kind of legitimate environment or legitimate set of circumstances that is causing some pattern outside the norm, and that helps to then roll into looking at things like predicting the future, right? What will the operating state of this machine be now, based on the fact that we've seen this trend over the last month, the last week, the last day? What do we expect to happen going forward with that device, and when do we expect it to fail? So these are some of the areas where analytics have become increasingly important, and even over the last 2 to 3 years, you're seeing a huge trend toward people wanting more analytics. So continuing on the analytics thread, one of the things you want to be able to do, and this is where, again, building on the integrated data center management thread, you use multivariate analytics, okay? So multivariate allows you to bring in all sorts of data. And if you think about that integrated center, whether you're looking at your building automation system, your data center infrastructure management system, ITSM, you name it, bringing in data from all those various and disparate sources allows us to kind of discern much more relevant and deep, meaningful patterns that maybe we didn't see before, maybe we would never see because of the depth and the breadth of the data that we're faced with. We have so much coming in, but how do we actually do anything with it? And this is where you really need an analytics platform that allows you to account for multivariate systems. It allows you to do things like advanced preventative maintenance, as we already talked about, predicting failures on a particular piece of equipment or an entire set of equipment. What's the correlation of those items, right? If you have a cooling unit in alarm, what does the surrounding area look like? Is it just is there a particular rack of gear that's affected by it? Or do you have, massive problems coming from all sorts of temperature and humidity sensors in that environment as well? So you've got to be able to sort of tile that together and correlate it. Optimization. So certainly using application behavior and anticipated usage to optimize thermal and facility management is a key item. And then lastly, I would even say things like security anomaly detection. So if you have physical security systems, or you're integrating your OT and IT systems together, you have to look at an entire, and what we said here, parking lot to application realm of possibility. From the time someone badges into the campus to the time they enter a data hall to the time they open a rack and start to do some function inside that rack on a piece of gear. Are they tracked? What do we know about them? What are the anomalies in any kind of workflow you see there that are causing you to have concerns or causing there to be problems or interruption of service? So again, another area where analytics can really help. So leveraging analytics is one of the key items you're going to do to optimize your data center operations. And I've kind of already mentioned anomaly detection capabilities. And again, I'll just restate. This is really allowing your system to discern where your infrastructure is running outside of an expected behavior pattern, right? So does an anomaly always mean a problem? Absolutely not. It may just mean that something perfectly normal is happening, like a particular business group is running a workload every Saturday morning at 9 a.m. for the last 6 months, and every time that happens, you're getting some kind of anomaly that is indicated in your system. But it's good then to be able to correlate that and understand where you have problems and where you don't. It also allows you to do things like modify your thresholds so that they're more appropriate to your environment and allow for things that you don't consider to be problematic any longer, and so that you can just continue to do your work without getting a deluge of constant alarms and notifications on things that you just don't care about. The worst thing that could happen when you're dealing with that environment is for you to become desensitized to the notifications that you're getting, because eventually once that desensitization happens, you will miss something critical when it does happen, and that's a bad day for everybody, right? When the other side of this is, once you start to be able to detect these anomalies in how your infrastructure is behaving, you can then begin to forecast how that will function going forward. So as you know, what are your leading indicators for equipment failure? This is a key item, right? If we watch a computer room air conditioner over time start to have more and more anomalistic behavior in shorter time periods, then it stands to reason, but it would be better to have some analytical platform to tell you this, that you know, you could predict some sort of failure, and it'd be great to have the system tell you when that is likely to happen within some degree of confidence. And these things exist, right? These platforms are out there today, and they can take a huge data source of integrated data sets coming from multiple systems in the data center to produce and tell you where you're going to have these sorts of failures, or you know, within a certain realm of confidence. Okay, so now I want to move into discussing security a bit. Security is both a physical and a cyber consideration, of course, right? You have a huge impact of connected systems. You'll probably most remember the HVAC vendor eyed as entry point for target breach, right? And this was several years ago, huge problem, and everybody said, okay, well, it looks like there was some weakness exploited in the HVAC firmware that then allowed a major hack to happen. So certainly kind of a cyber criminal attack. But then last year, around the holidays, we had AT&T with a huge problem because of an actual explosion, right? So you've got both the physical and the cyber side of things that are coming to play here and really need to be addressed. Most data centers I talk to have implemented some kind of great physical security system. They know when people come into the building. They know when people go into a rack. You obviously have logging in place on applications and so on. So there's all kinds of capabilities. But you want to look also at things like, all right, well, once something like a breach happens at a particular rack in the data center, what are the next steps? What should happen automatically as a result of that? Should we lock the room and then make sure that you know, until someone gets there to check out the situation, nobody comes into or leaves the environment? You know, so the systems, again, it's another discussion around integration, but it's really not okay to any longer keep the systems that have been traditionally separate. We want to make sure we're integrating everything so that we understand what the impact is all the way up and downstream from one failure or from one breach. And you know, the other thing I would say about this is that customers are becoming aware and concerned. So just while we have the difficulty explaining what a data center is and what it's doing, we also have these catastrophes where people's lives are actually interrupted. They lose their cell service for a day. They can't message. They can't get on their apps, what have you. Once that happens, they then become kind of acutely aware of the data center and what that means and what levels of security must have been breached in order for that failure to have occurred, right? So this is the type of thing where it's becoming much more front of mind, and everybody is much more security focused. And I think, obviously, I think we'd all agree that that's really a good thing. The other thing I would say is you want to address your security concerns comprehensively. So obviously, you know, let's first determine a plan, right? We want to make sure that we can continuously perform asset integrity monitoring. How are the devices performing? What does that really mean? Well, you're going to start with baselines, and we'll talk about this again shortly during the metrics section, but create baselines. Where are we today? And frankly, everything that we start to think about from a security standpoint, let's measure that moving forward. You definitely need to incorporate manufacturer and industry-known vulnerabilities. So there are systems out there, as I'm sure most of you are aware, that will incorporate vulnerabilities that are known. So if a particular manufacturer has put out a large power unit and there's a vulnerability in the firmware for that unit, that'll be addressed, that'll be known and cataloged, and there are systems out there that can sort of overlay, but here again, you're looking at integration. Don't just overlay that data with the building automation system, but overlay that with the systems that understand which workloads are affected by that critical infrastructure, right? There is another case for the entire integration end to end of all the systems in your data center. And then looking at things like non-traditional attack vectors. You really, when you're thinking of security and keeping that front of mind, you need to be thinking of adversarially, okay? In other words, try to take the hat off that you wear today and put on the hat of the person that is trying to attack you. What does that look like? If you were them, what would you do to attack your data center? And I think thinking adversarially is always a good idea when it comes to security, because if you're honest with yourself and you're honest with what you know about your environment, you will think of things that could be exploited, and the idea there is to button those all down to the point where, the likelihood of any kind of real breach having major impact on your business or users is absolutely minimized. And then do things like automate your discovery and actions. So what are the remediation tactics? What will you do when something does happen? Automate that. Automate your systems to know what to lock down, what to change, what to open up, whatever the particular case is that needs to happen as remediation. Automate that as much as you can. All right, so now we'll move into discussion around sustainability. And frankly, I'm not sure there's a hotter topic in the data center market right now. Data centers are a huge target for sustainability. You've got everything from, of course, our industry analysts running surveys and trying to glean what data centers and data center operators are really doing to address sustainability. But you also have major vendors, major players everywhere. And I know these have been discussed today in many cases. You've got, Google saying, well, Google's been carbon neutral for several years, but now they're changing and doing their compute kind of following the most efficient areas to do the processing during the day on a 24/7 basis. You're looking at things like discussions around, okay, well, we're all driving towards sustainability, but what will the rules, what will the governance look like of that? And then you have others that are just making, huge claims. I know we have Microsoft saying we're not going to use any diesel generators by, I think, the year 2030, maybe even sooner than that. So you have, lots of things like identifying, well, what's our most carbon-heavy footprint, and which equipment do we have that's the most inefficient, and what can we do about that? So again, very huge topic in the market. I don't think I've seen a bigger one right now, but let's continue down this thread for a while. So if you look at sustainability in the data center, I would say it's got really both internal as well as external considerations. When I look internally, I think of things like, well, what kind of efficiency gains could I get in my environment, period, right? And that can be everything from, staffing and workflow and the way things work to thinking about things like, well, when I order new equipment during my procurement process, have I built in making sure that we're leveraging vendors and equipment that are using sustainable packaging, things of that nature. And as you even design your data center, right? If you're looking at a new build, there are a ton of considerations around sustainability and how you would design that data center. From an external perspective, certainly leverage renewable energy resources wherever available. And you can talk to the utilities and so on to make sure that you're getting access to and leveraging those sources as much as possible and as appropriately as possible. I already mentioned construction processes. You can also look to design out equipment that has heavy carbon footprint, right? So again, looking at the Microsoft example on diesel generators, it's more than just making a claim around we're going to do that. They've done a lot of testing with hydrogen cells and so on to see just how long could they run the environment with alternate energy sources that don't include the diesel. And so it's hugely important, but again, one of those external considerations. You also have things like being able to improve sustainability through process, right? So what does this mean? Well, you can develop organizational processes for things like sustainability certifications, ensure that the staff is kind of managing the environment in the most sustainable way possible, putting things front of mind, like, are you using the proper packaging? How much time is being spent on this? When you do this task, you know, you could even take it down to how much power and cooling is being used to do particular processes or workflows inside the data center. All of that eventually can add up to sustainability improvements and gains. You should definitely establish procurement guidelines. I mentioned this previously, to ensure that you're purchasing efficient equipment, and not just efficient equipment, because we know that, especially on the IT side of things, the refresh on equipment and what it can do is so frequent that it would always outpace your purchasing cycle. But looking at things like which vendors are leveraging sustainable packaging requirements and things of that nature also are key items to consider here. You should always identify points in your equipment deployment processes for inserting or tweaking efficiency gains. So again, what's taking more power than it should in order to deploy gear? What's taking more lighting than it should in order to deploy gear? And these things all sound, well, they don't all sound small, but they can sound small, but you know, they all add up. And that's the real deal here is, as I mentioned earlier in the discussion, we've been measuring our effectiveness, especially around things like power usage effectiveness, for years, right? For over a decade. So people have gotten pretty good at getting down to a certain range. But in order to really sort of tweak and start to get the next level of efficiencies and gains out of your operation, it's going to require excellent measurement, but also, you know, the ability to insert or tweak your processes to make sure that you're getting that next level of gains. The gains will be smaller, and so over time they add up, right? And that's an important thing. Okay, and then the last thing I would say is, and this ties it back to analytics, you're going to get rich sustainability metrics out of systems that are integrated and comprehensive in nature. So with the increased focus on data center sustainability, then data centers are absolutely going to have analytics that represent an end-to-end picture of what the environment is really doing. Okay, so again, visibility into power and cooling anomalies give you good leading indicators for inefficient equipment. Is the equipment working its best? Is it functioning optimally? Probably not. And the more anomalistic behavior you see off of it, the more likely it is that that's the case. And so you're going to be able to identify those things and improve them. You want to be able to forget the equipment inside a data center, look at the data centers themselves. Which data centers in your environment are ripe for, you know, consolidation or closure? If you have multiple data centers, chances are you're not completely maxed out on capacity in all the environments. And some of them may not be optimally designed. Some of them may not be optimally running at this point. And so is it better to consolidate? Is it better to close and build new? You know, these are things that as you really start to focus on sustainability, there are questions you're going to be faced with and things that you're going to want to answer. And then I would say also looking at things like forecasting performance for your critical infrastructure to see when they become less efficient. And again, that really ties into your analytics engine and what it's able to do from determining where there are anomalies on infrastructure, and then looking forward in a forecasting fashion as to what it's going to look like going forward. So tying all this back to the integrated data center management and analytics is key. All right. And the last section I'll bring up is the metrics and benchmarks. So, I had a COO years ago who said, if it moves, we measure it. And I think this is a really good approach the older I get, in that the more time goes on, the more you see that understanding how the system is functioning and what the metrics are you're using it, the more you realize I want to be able to change those metrics. I want to be able to mature my metrics. I want to be able to measure different things against a historical data set and so on. So, the more that the computing fabric matures and becomes complex in the data center today, the more your old metrics start to lose relevance, right? And they become less and less important or less and less relevant because the environment has changed, the environment has matured, and so must your metrics. So to give you an example here, in a hybrid computing environment, you need metrics that identify the optimal location to move workloads based on things like, what's the workload type? What's the criticality to the business? Is it your ERP system, or is it, something much less critical to your day-to-day business operations? What's the risk of moving a workload to this location, and should it be done at a certain time of day? Is there, and if during that time of day, then does the ability to power and cool that environment become less expensive? That sort of thing, right? So you need to really look at evolving your metrics and let them grow with you. And then this also, and this is the thing that gets exciting, I think, especially when you take any kind of emotion out of it and you just look completely objectively at your environment. The data center market today presents the opportunity for new metrics, right? New metrics could be anything, but just to give you a few ideas and get the creative juices flowing, you want to look at things like carbon footprint per workload, or cost per workload, or what's your total carbon usage, or risk per workload. So when we realize that, well, the entire reason for the data center's existence is critical business workloads, and those workloads are, everything in this environment is built around supporting them, then you start to see the critical nature of actually understanding and reporting on those workloads and what else they can be tied to, like cost and risk and so on. So it's incredibly important to not just baseline, and we talked about that a little bit earlier. Definitely you have to create baselines as to where are we today, what do we know about our environment. But when I have sustainability discussions with customers and prospects, I have to say a lot of times they're still at the phase where they're just not sure what they need to measure. They're not sure what they need to look at. And I would propose that rather than, just sort of waiting for someone to tell you what to measure, or letting someone tell you what's important, go out there and start to define your own metrics, create new metrics, and work with others in the industry to do so, because that's how they gain adoption. That's how they become important and prominent in the space. And I think that it's certainly going to be something we see happening out of necessity as we move forward. And so let me just take a slide here to sort of summarize everything we've talked about today. First, integrating the disparate systems in your data center to increase efficiency and resiliency and availability is absolutely key. I, again, would argue that rather than putting that integration off as a to-do sometime in the future, you should start there today and let that integrated system flow for a bit and create the baseline that you need to go forward and look at then how do you improve? How do you become more sustainable? How do you ensure your environment is more secure? And what are the analytics that you need? And what are the metrics you're going to create to continue to report on and see improvements in your integrated system? So that's first and primary, right? Obviously, the explosive growth and the size of data being generated today requires advanced analytics for all the reasons we've talked about. You need to be able to discern hidden patterns where, your human eye, the human operators just simply cannot do that anymore. There's far too much data for that analysis to really be done by an individual or even a team. Physical and cybersecurity concerns, data centers are going to continue to grow. Remember, think adversarially. Every time you think you're secure, there's someone out there trying to determine and find why you're not, and then exploit that. So always, again, take your hat off that you wear day to day and put on the hat of the guy or the person who's trying to harm you. And that will always help you start to look a little more objectively at your environment to understand where there are problems. And for, by all means, you've got to bring those to light as soon as you can, rather than knowing about them but letting them sit. So businesses seeking to achieve higher sustainability standards are placing their data centers under heavy scrutiny. Companies know that the data centers are huge consumers of power, and sustainability has got to be a key item for them to focus on as it pertains to the data center operation and just becoming more and more green. But there are both internal and external considerations in the data center that you can look at. So it's not just how do I use more wind or how do I use more solar energy? It's much more than that. Being able to tweak processes and, from everything from procurement to work orders is key. And then last, metrics and benchmarks. Again, if it moves, measure it, right? If it's a system that you've got more than enough data at this point. So what metrics are important to you? Consider developing new metrics that suit your needs and your business's needs, and then make those part of your day-to-day, part of your go-to-work mantra every day. This is something we're going to measure. This is how we're going to know that we're improving. And then from there, continue to tweak and drive efficiencies. With that, that concludes my portion of the presentation. And Chris, I think back to you for any Q&A. Okay. Well, here's one question that has come in, and I'll jump in. I don't know if Chris has lost audio. So one question came in: how does ITSM like ServiceNow fit into this? And I think that's a great question. So when I talk about the integrated data center management and truly looking at all of the systems that go into managing, monitoring, and so on in the data center, ITSM is a key portion of that. If you look at for instance, a data center infrastructure management solution would all the time, you'll see that those systems, especially any system that really uses a workflow engine or anything like that, is integrated with the ITSM system. So using ServiceNow as an example. So you could have integration with ITSM, integration with CMDB, integration with various and sundry other systems like security, right? So having IT and OT vulnerabilities sort of mapped onto each other. So that's sort of one end of the spectrum. And then on the other end of the spectrum, I'd say you've got the building automation system, building management systems, and all of the systems that those integrate with, such as fire and suppression, lighting and control, security, physical security systems. So as you start to look at integrating all of those things together and sharing data from the quote unquote facility side to the IT or IT operations side, you then really get a more comprehensive and a fuller picture of what, and then you really do accomplish an integrated data center management solution.
Jeremy, apologies for that, and apologies to the audience as well. Timing for the phone line to disconnect.
No problem.
As I was saying, And thank you for taking that question.
Sure.
As I was saying, thank you for the presentation. I think you really touched on a lot of the hot topics. I mean, it's been a good view of IDCM in context of these topics, and you touched on pretty much all of the big ones that we've been explaining today. And the great thing is you've shown us how to achieve these goals and how to do these things. So we have got time for a few more questions. One of them nicely ties into one of these key topics that we've been exploring, edge. And I wonder if you could tell us, Jeremy, how IDCM works in an edge deployment.
Yeah, so with edge deployments, it's a great question. And I know I touched on it a little bit during the session, but the edge deployment, the idea can be anything from, it's a very, you've got multiple or many small environments, like they're just a few racks to one rack type of thing, all the way to huge content providers just putting an entire data center on the edge to reduce latency and put the compute and processing closer to the end users. At the end of the day, integrated data center management is really key to managing edge environments, because you could have a situation where those environments really don't have staffing, or not the kind of staffing you would see in a traditional enterprise environment. You've got to be able to identify problems and autonomously manage the environment as quickly as you can from a remote destination, typically, right? More and more when I talk to someone who has edge deployments, they're talking about, well, I sit in Boston and I manage 300 data centers across the country, and so I get notifications from the infrastructure in those environments, but I don't know what the root cause is, and I really don't know what the impact is to the overall until sometime later down the road. By integrating all the systems in play, you will get a much more comprehensive picture of which workloads are going to be impacted, for instance, right? So if you have all of your if you have certain processing being done at one particular edge location where you have a notification, you need to be able to, at a glance, bring up a screen that says, this is what the impact is. You're going to lose access to your ERP system or something of that nature, right? So leveraging all of these systems together and then being able to build out the associations from the infrastructure down to the workloads is absolutely key, and will only improve the management of an edge environment.
Got you. That makes sense as we're moving towards, I guess, as near as we're going to get to lights out data center. The next one, simply, that's come in is, what are the key indicators that drive IDCM? What are the drivers there?
Sure. Yeah, that's a great one too. So I would say first, capacity, right? Capacity drives a real need for integrated data center management. If you were to go out and say to most people, and I can give you all kinds of examples, but if you were to go out and ask most people, all right, well, once you identify a power anomaly or a security breach, how quickly can you minimize the impact of those events on your critical workloads, on your IT systems? I think most people would say, I'm not really sure. Power chain things, sure, we understand that, and we can understand when we need to move workloads, but still in the traditional sense, where there's a real division between facilities and IT, one hand doesn't necessarily know what the other hand is doing, right? And it's when you integrate the systems, and by this I mean not just creating a new system that everybody is expected to go and adopt, but integrate your building automation system, which is the trusted system of your facilities folks, with your data center infrastructure management system, which is the trusted system of, in general, your IT or IT ops folks. Then they both trust that the data that they're seeing and leveraging is true and accurate in their data, right? And that's why it's so important to look at integration versus a net new improvement. So capacity and understanding the capacity for to compute new workloads under the existing infrastructure is key. But you also have other things like, if you could look at how would visibility into which workloads and assets are affected by your power and cooling chains benefit your business? Well, a lot of people aren't entirely sure of that, right? We want to say, well, I need to put 10,000 servers into my data center, and I don't know if I have capacity to do that. So tying those in with your critical systems are key. And so, those are a couple of examples, and I think the list kind of goes on from there. But as you start to think about integrated data center management, I think you'll find that the questions continue to expand and provide a lot of new use cases for you to think about as far as what efficiencies you could drive, how much more optimized could the system be, and so on.
Great. That ties in with another question that's come in from someone managing multiple data centers. You mentioned building automation systems there. What about multiple building automation systems? Does IDCM function in a multi-BAS environment?
Yeah, absolutely, and it's a fantastic question because it's an incredibly real-world scenario. So I would say it's the norm where data center operators have multiple buildings, multiple data centers in their environment, that those data centers, because they're acquired at different times or through different regions, or you name the reason, there are different building automation, building management systems in play. And integrated data center management, if done well and when done effectively, will be able to incorporate and have sort of a translator or an integrator in the midst that will allow all of the data from those various and disparate building automation systems to be normalized and then fed into a centralized user interface that allows for the reading and understanding, analyzing, metrics, definition, and so on around that. So that is a key element and a great question.
Perfect. The last question I wanted to come to, in a multi-cloud environment, can IDCM enhance the virtualization capacity, storage capacity?
Yeah, I think that, understanding that the question the way I am here, I would say absolutely. And the reason is because, again, in that multi-environment, you have to, your virtualization systems will easily move workloads around, right? They'll move it to different critical infrastructure, different IT infrastructure as per your guidelines, as per your definitions and configurations. But if you were to just do that in a vacuum and you don't understand the impact that it has on the infrastructure, for instance, if you're in Northern Europe and you have multiple remote locations in Southern Europe and there's a heat wave coming tomorrow, do you really want to throw a bunch of the processing over to those Southern European data centers just based on the rules out of your virtualization system? Or would you really like to know that absolutely not, right? If we do that, we need to start pre-cooling the environments down there today so that we get much more efficient cooling out into that environment rather than having to do some sort of ad hoc last second cooling of the space. And then, you don't want to just put workloads somewhere because the virtualization system can do it. Through an integrated data center fashion, you would be able to understand that the critical infrastructure and cooling and power specifically can support the move of those workloads prior to doing it.
Got you. Look, thank you again, Jeremy, and the wonderful team at Enlight Software, of course, for the presentation and for fielding those questions there, speaking with me. It's been a pleasure. Thanks for taking the time to share your insights with everyone.
Thank you all, and really appreciate the time, and I hope you continue to have a great conference.